your AI coding tool is helping. It understands the project, writes the plan, starts making progress, and then suddenly you hit a limit. Tokens gone, quota finished, context too large, or the tool just stops when you need it most. So today I am testing a practical recovery workflow. Claude Code stops mid-task, and local AI helps finish the project. The rule is simple. Do not panic and do not paste random files into a new chat. Use a repeatable recovery loop. Plan, pack, prompt, patch, and prove. Save the cloud AI plan. Pack focused repo context. Prompt the local model with constraints. Apply the smallest patch. Then prove it with build, tests, and diff review. For the demo, I am using a small ASP.NET Core API. The task is realistic but bounded. Add a health endpoint. Fix a ProductRequest validation issue. Add one test that proves the health endpoint returns success. This gives the AI 3 responsibilities: understand the project, make a small code change, and verify the change. Start the way many developers do. Ask the cloud coding tool to inspect the project and create a safe plan before editing. The prompt is not complicated. Find where the endpoint should go, identify the validation problem, and suggest the safest test to add. Then the real incident happens. The tool hits a limit. That is the moment where most workflows fall apart. Now pack the context. Local AI is not magic. If you give it messy context, it gives you messy code. For this task, use the saved cloud plan, Program.cs, the relevant request model, validation code, and the test project shape. If the repo is larger, this is where Repomics helps because it can turn the repository into AI-readable context. But the rule is the same. Do not paste everything. Paste what matters. The local prompt is more constrained than the cloud prompt. The model does not need to redesign the app. It needs to continue the task from the plan. Tell it to use only the provided files, avoid unrelated architecture, show exact files, return small code sections, and explain how to test the result. Smaller local models can help, but they need guardrails. Now apply the patch carefully. First, add the health endpoint in Program.cs. Simple, fast, no database dependency. Next, fix the validation issue in ProductRequest. If the product name is required, the local model should not rewrite the whole model. It should fix the rule and move on. Then add one useful test for /health, not 20 tests. One focused test that proves the recovery worked. Now prove the change. Run .NET build. Run .NET test. Review Git diff. AI-generated code is not done when it looks correct. It is done when it runs, passes checks, and the diff makes sense. If the build fails, paste only the error message and the relevant file back into local AI. Ask for the smallest fix. Keep the loop clean. So what did local AI do well? It continued a small task, drafted boilerplate, explained the change, and worked from focused context. But here is the honest part. Local AI can be slower. It can miss architecture decisions. It can hallucinate methods that do not exist. I would not use it blindly. I would use cloud AI for planning and hard reasoning, local AI for backup continuation, and Git for safety. Here is the workflow I would actually use. Start with cloud AI when you need strong reasoning. Save the plan. If the tool hits limits, switch to local AI. Give it only relevant files. Ask for small changes. Run build. Run tests. Review the diff. This way, one AI tool stopping does not stop your whole project. Subscribe to Half-Stack AI for practical AI coding workflows without the hype.